Welcome everyone to today's presentation, Taking the Effort Out of Wireless, Smart Wireless is Winning, brought to you by Power & Tel and Comtrend. My name is Mike Riddle. I'm the Training and Development Coordinator for NTCA, the Rural Broadband Association, and we're happy to welcome today's presenter. Richard Criscrege is a product manager for Comtrend North America, specializing in professional-grade wireless solutions for business and large residential applications. Richard's career has spanned over 20 years in the technology industry, and through his strong understanding of networking, he has become a trusted advisor for service providers. His responsibilities include the evaluation and development of complementary related products and partnerships within his category. Now I'm happy to hand off things to Richard, and we'll begin the presentation.
Hello, everyone. Thank you for joining. Thank you, Mike. So let's go ahead and just get started. Okay, today's home wireless. If you would have told me, say, 10 years ago that I was going to have 30-plus wireless devices in my home, I would have told you that you're nuts. But today, that type of environment is definitely what we're experiencing. With the combination of laptops, cell phone, tablets, IPTV, high-definition televisions, wireless light bulbs, thermostats, the home network environment has really become saturated with Wi-Fi products. This has been a challenge for the Wi-Fi industry to try to keep up with that type of flow. In addition, 10 years ago, if you told me that my wireless was going to be the bottleneck, I would again said that you're nuts. There's no way. My 802.11b at 11 megs or 11G at 54 megs is going to be more than enough to satisfy my internet connectivity. But again, because of the advent of newer technologies with broadband, the introduction of HD TV, 4K TV, and all of the other sources of streaming video, the wireless in your home has really started to become the bottleneck. No longer is 11 megs going to always outpace your broadband connection. Even 54 megs won't outpace some of your broadband connectivity. This caused quite a few problems as a hardware manufacturer because we really only have a few things that we can manipulate to improve the technology or the experience for the wireless environment. Of the three major components, the first one we're going to talk about is transmit power. Of course, higher power means a longer broadcast range, means that you can reach out to remote devices at range. But there are limitations that we have to work within as a manufacturer. The FCC imposes limitations on the amount of transmit power. There is the stigma of how much radiation we're going to be pumping into the residents, and the idea of being a good neighbor to not flood the entire region of, say, a multifamily dwelling with latent radiation from all of the different wireless devices. So with high power, additionally, there are some other side effects when it comes to cranking up the power output. If you increase the power output, say, beyond 800 milliwatts or up to 1,000 milliwatts, the radiation pattern from the wireless device starts to deform. And it is no longer a clean bubble. It starts to deform into a donut football shape. This deformation makes it difficult to plan and track the radiation pattern within the deployment, so it makes it difficult to plan the deployment. So increasing the power or the gain on the antennas of a wireless access point or wireless router isn't necessarily the best idea. Additionally, not only do we have to have high power, we also have to have high sensitivity. Wireless is a two-way conversation. If you're going to have a high-power transmitter, you're going to have a highly sensitive receiver. Basically, the concept is if the remote device, say your iPhone, is only broadcasting at 32 watts, but your access point is broadcasting at 800 milliwatts, clearly the access point has to have a receiver that is much more sensitive than the receiver that's on the remote device. This receiver sensitivity also has the same limitations as the power output. You can't just continue to increase the receiver sensitivity to an infinite degree, because not only will you pick up the iPhone that's at range, but you're also going to pick up a great deal of interference from the surrounding environment. So you're going to start picking up microwaves, baby monitors, cordless phones, just a lot of radio interference when you start to increase the sensitivity, say, above 100 dBi. And finally, dual band, or tri-band in some cases. It's the number of radios. So basically, we can add more radios to an access point. Right now, originally, it was a 2.4 gigahertz, which provided performance up to the 54 megs. When the wireless need started to exceed that, we went to a 5 gigahertz, and then we have dual band to where the product will go ahead and have a radio for 2.4 and 5 gigahertz. But again, this is still just part of the limitation on how we can manipulate the hardware. Moving forward, the only thing that we have left to do is features, because we can't change the fact that these three hardware tenets are the only things that we can work with. Before I move on to the features, I just want to get an idea of the generations of wireless. For us at Comtrend, we consider the first generation of wireless to be the wireless that was provided by your gateway or your router. The second generation of wireless is where we manipulated those three primary features to crank up the maximum amount of power, as much sensitivity as we can, and start stacking 2 and 3 radios, to where the second generation wireless is where we were basically just juicing the hardware as much as we could to have a single wireless device actually manage the entire property. Third generation wireless, for the purposes of this presentation, is going to be multiple devices functioning as one. So back to Wi-Fi innovations. So these innovations that you see on the screen, multi-user MIMO, beamforming, band steering, these are all of the basic innovations that were applied to the three tenets of hardware to try to maximize the performance. But these really are just manipulations of the hardware. For instance, band steering is just a way of optimizing the radios to where it will steer you from the 2.4 gigahertz band to the 5 gigahertz band when appropriate, and then as you start to fall out of the coverage bubble for the 5 gigahertz, it'll step you back down to 2.4 gigahertz. Beamforming, multi-user MIMO, those are just manipulations of the transmitter and the receiver to try to optimize the amount of performance you are getting from the hardware. So those are basic features that were utilized to try to step up the performance of a second generation wireless device. Moving forward, we're going to talk about mesh networking. Now, mesh networking is kind of a complex subject because the term mesh networking has been adopted to encompass pretty much everything that we would consider to be in third generation wireless, which is wireless linking, automatic redirections, a self-healing network, fast roaming, traffic steering, zero handoff, all of those wonderful features. Unfortunately, not all of those are actually considered part of mesh networking. Mesh networking technically is just the wireless infrastructure. It has nothing to do with performance and handoff. It has everything to do with stability. So before we move too much further on this subject, I'd like to go ahead and just really clarify what mesh networking is and what is third generation wireless. We'll call that meshy. So for a mesh network, we're going to go ahead and have, this represents a single access point with its coverage bubble. For this demonstration, we're going to go ahead and have multiple access points. On this display, I did lay these out in the configuration of a telephone keypad. It just makes it easier to remember. As far as wireless linking in a mesh network environment, we're going to go ahead and we're going to connect access point number 1 to access point number 2. This is a wireless to wireless connection. We're going to connect all of the access points, again, wireless to wireless. This diagram is not being portrayed as the ideal or optimal solution for a wireless to wireless network. This is just to convey these devices are connected in a pattern. This is considered mesh networking. It is not considered, it doesn't have anything to do with handoff, fast roaming, or anything like this. That is just the mesh network to where all 10 access points are functioning as a single unit. Another component of mesh networking is auto redirection. What auto redirection is when an access point fails, in this case, say access point number 8 drops off the grid for whatever reason, that access point number 0 is now completely isolated from the rest of the network. This would cause a service interruption for anybody who is attempting to connect to access point 0. But again, with mesh technology, access point 0 would automatically reconnect to the nearest and best available access point. In this particular example, it has reconnected to access point number 7. This reconnection is done automatically, and then the service for the people on access point 0 is restored. Self-healing, a self-healing network is also part of a mesh network. What self-healing is that in this example, we still have a service coverage gap between access points 4, 5, 6, 7, 9, and 0 because access point 8 dropping off created a void. What self-healing does is that the system will automatically increase the power output and coverage of the surrounding access points to cover the gap until the product is replaced. Again, still about mesh network, but nothing to do with performance. It's all about the stability of the network. Fast roaming. Fast roaming, again, is commonly referred to as something within mesh networking, but it really isn't part of mesh. But it is part of third-generation wireless, so it has adopted the moniker of being a mesh network feature. What fast roaming is, a client that is outside of the network sphere can enter the network. This is not fast roaming, this is just joining the wireless network. But when the connected client that is currently connected to access point number 3 moves to access point number 6, they do not actually experience any type of delay or handoff latency. This is done by access points number 3 and 6 recognizing that the connected device is moving outside of the coverage bubble of 3 and towards the coverage bubble of 6, and then it does a managed handoff. This handoff is done by the APs and sometimes by the remote device itself. When the device moves from access point number 6, let's say past 5 and all the way to access point number 4, again, that is still considered fast roaming, and then it would be handed off from access point number 5, from 6 to 5, and then 5 to 4. There are two basic types of fast roaming that are currently available today. The first is an IEEE standard, 802.11k and 802.11r. This is where the wireless access point and the client device must both support the IEEE standard. And both the wireless device and the remote client come to a consensus as to what is the best course of action as far as moving from one access point to the next access point. One of the key advantages of this is that it is interoperable between any IEEE standard device, and one of the disadvantages is it isn't necessarily going to be supported by all remote devices. Some of the older remote devices, or actually a better reference would be some of the devices that are not the newest. So even if you have, say, an iPhone 5, possibly an iPhone 6, IEEE 802.11k and R are not supported, but in your iPhone 7 or your Galaxy 7, it is. The other option is the proprietary features that are available from a multitude of manufacturers. The advantages of this is that it does not require the involvement or cooperation of the remote device. So it is absolutely compatible with every single wireless device that connects to it. Its key disadvantage is that there is no interoperability. So if you were to deploy a proprietary client steering solution within a network environment that had other wireless devices, say your gateway, the likelihood of the remote device, the secondary access points interoperating with your gateway are pretty low. But it does offer you the flexibility of supporting every single wireless device that actually connects to the network. One subject that I did not cover with slides on mesh networking is traffic steering. Traffic steering is kind of a component of fast roaming, but a little different. Traffic steering is much more akin to, say, band steering, where band steering moves you from the 2.4 gigahertz radio to the 5 gigahertz radio where appropriate. Traffic steering will move you from one access point to another access point without simply using your connectivity parameters for that access point. So for instance, if you are closer to access point number 8 on the previous diagrams, but it is currently overloaded because there are just so many people connecting to access point number 8, say favoring the 0-9 quadrant of the bubble coverage, the system will actually redirect you to an access point that is further away, knowing that you would actually receive a better internet experience or network experience because of the fact that that access point has more overall bandwidth available to it, even though it is not necessarily the closer access point. Now, don't get me wrong. All of these innovations are great. They really are. And they're really, really good for our customers and the customer experience. But they really are end-user-centric innovations. What we are very pleased to announce here at Comtrend is that we have started to move down the path of service provider-driven innovations. We are looking to make the managed wireless access point experience or the managed wireless network experience within a residential or commercial property to be not only easy to deploy, easy to maintain, but also easy to troubleshoot. The way we're doing that is by two features. One, we are calling Wi-Fi Extend, and the other is to integrate TR69 into the wireless access points themselves. Wi-Fi Extend. Wi-Fi Extend is a feature that allows remote access points, whether they are ceiling-mounted, wall-mounted, or even power grid units, to receive configuration data from the existing gateway that's already at the premise. This will allow the gateway to provide the SSID and password necessary for the remote devices to seamlessly connect and create a large mesh network. This is done simply. In this example, we are using a ceiling-mounted wireless access point fresh out of the box. All of the parameters are set to default, and we have a Comtrend 6895 gateway, SSID, my house password, PW123, and it just happens to have an IP address of 0.1. In this example, we are using an Ethernet cable to connect the access point to the gateway. Once the access point is connected to the gateway, it will request an IP address, as all network devices do. When the gateway receives the request for an IP address, it reciprocates and provides it with an IP address, and in this case, we went with 0.15, but it will simply pull from the DHCP table. Immediately following that, the access point is going to go ahead and query the network and request configuration data from a Wi-Fi Extend server. The server feature is built into the 6895 gateway. The gateway will then respond with the configuration data, my house, and PW123. What this does is this allows the gateway and the remote access points to be synchronized in such a way that if you make changes to the gateway pushes those changes out through the network automatically within just a few seconds. So if you are utilizing TR69 or some other remote management platform for the gateway, you can go ahead and use the gateway as a proxy to control the access points within the property. This does not have to be done with, say, a standalone wireless access point that's connected via cable. It can also be done with WDS, and it can be done with power grid units. The real advantage of the power grid units is that if you have a customer that has let's say a dead spot on the far side of a large home or in the basement or on the second floor. You don't actually have to roll a truck anymore to extend their wireless because there is no on-site configuration that needs to happen with the hardware. You can simply mail them a power grid backhaul unit, say a PG9172, and then send them, say, a PG9172 AC for the remote location. Once those devices are plugged into the power grid and the 9172 is cross-connected to the gateway, it will automatically copy over all of the wireless information necessary for the wireless network to be extended. TR69. The great thing about TR69 is that the telco industry already utilizes it, and most of us have an ACS system that will allow us to manage our perimeter devices. With TR69 support on the access points, there's also a built-in stun client. So even if you do not intend to utilize a TR69 gateway or you do not wish to use a TR69 gateway to control the access points within the property or in the deployment, you can manage the access points independently, individually, via your existing ACS systems by utilizing the TR69 and the stun client. If you are using a top-tier ACS platform, in this case I'm going to use FinePoint as an example, this makes it extremely powerful. No longer are you limited to just pulling real-time data as it is when your customer is calling. I know a lot of us have received the call, something along the lines of, you know, my family was complaining today that the internet and the wireless in our home is slow in the late afternoons, but seems to speed up later in the evening. So by the time I get home to call you about this service lag, the problem has already gone away. Again, typical, I really can't help you unless the problem is happening right now because I have no way of looking at the real-time data to see where the problem might lie. With an ACS system with gateways and access points that are TR69 compatible, the ACS system can be set up to where it will actually do data logging so that you can actually tell the customer, you know what, I'm going to put your property on a data log for, say, the next 2 days, and we're going to go ahead and call you back, and then we'll have a better idea of what is actually going on. And then the system will actually data log the number of devices connected, the amount of bandwidth each device is absorbing, which access point it is actually connected to, and a variety of other parameters that could help you diagnose why is the customer experiencing such a slowdown so regularly in the late afternoon. In this particular example, which is a real actual example, the telco runs the log and is able to call the client back and say with certainty that we do see the internet slowing down for your internet experience slowing down, but the internet itself is actually running as it should. What's happening is that there are a couple of devices on the network that seem to connect every day at 3 o'clock, and we're just going to call that device Johnny and Susie's laptop because they get home by about 3 o'clock every day. And they proceed to watch videos and HD content and all of that other wonderful stuff between 3 and 5 until their parents come home at 5 o'clock, at which point they are still complaining that their internet experience was slow all afternoon, but now everything seems to be working fine because now they're actually doing their homework. This is actually a real example that did occur, and utilizing TR69 with the access points was able to easily identify which client devices, when they were connecting, and what type of protocols they were using when pulling down the data. Wi-Fi Extend and the TR69 features are available on a variety of Comtrend's gateways on every single one of their wireless access points and most of their power grid units. Where to buy? Power & Tel. Power & Tel carries a full line of Comtrend products. They are a stocking distributor, so it's super easy to acquire products from them. Finally, I'd like to cover one last thing, switches. Smart switches, PoE switches, and large port switches used to be intimidating to the telco industry because it was a product and a series that they were not familiar with. Additionally, many telcos did not want to actually deploy a switch that actually is smart or managed, because then you'd have to have the technical team trained to manage it, the installers would have to be trained to do the installation, and it just really bogged down the deployments. What Comtrend has done is that we have decided to, what we are calling Telco Tuned. We are telco tuning our smart switches to where right out of the box, they are already set up to be optimized for IPTV, IGMP is enabled, loop detection, loop prevention, and QoS has all been pre-configured to favor video and IAD telephones. This is done, again, right out of the box, but there is a UI. If you so choose, you can log into the switch and take advantage of all of its other advanced features. But if all you're really looking to do is improve your IPTV with IGMP, you can take it right out of the box and deploy it without ever logging into it. That concludes the presentation part of this webinar. We are going to go ahead and do a Q&A, so please submit your questions. As you do submit your questions, we're going to go ahead and cover some of the standard questions that are presented to us pretty much at every single webinar. I have Walter here. Walter is a sales engineer for Comtrend, and he will go ahead and offer us the technical explanation for the questions. So, Walter, the first question is, what problems can I expect when installing Wi-Fi Extend?
Okay, since the Wi-Fi Extend is just a first phase where we're just doing basically an SSID and passphrase, the big challenge is before this Wi-Fi Extend to push to configuration, the encryption needs to be the same. Later on down the line, we are going to make this thing as part of the Wi-Fi Extend settings that's going to be changed, but for now, that is going to be the big challenge. But for all the Comtrend products, all our encryption is going to be the same, so it's not going to be an issue when pushing those configurations such as SSID and passphrase.
Excellent. The second common question is, does Wi-Fi Extend only work with Comtrend products?
Yes, this is actually a proprietary features that our product actually have that none of the vendors actually have as of yet.
How many access points does Wi-Fi Extend support?
As many access points as you can get in the same network. So as long as they are in the same network, as many access points as you can get on that Wi-Fi Extend.
Will these all mesh with one SSID for seamless handoff?
Yes, it will mesh all with single SSID for seamless handoff.
Is the controller an actual access point?
This one is a yes and no. If the CPE, if you're asking if the CPE is an access point at Wi-Fi Extend, yes, it is an access point. If the CPE is the controller for those Wi-Fi Extend end nodes, no, it's not. It is actually just a master that pushes configuration to those slave nodes or to those access points.
Okay, and that is the last of our pre-canned questions that we usually receive during the presentation.
Okay, and if we have a couple of questions then. If you have a question, just go ahead and input it into the Q&A box in the bottom right. First question we got in was, what about voice on your switches? We are talking about prioritizing voice on your switches since we sell VoIP with our internet offerings.
Yes, what we can do is we do offer custom code so that if there are any particular QoS or VoIP settings within the switches that you need to have pre-configured prior to it being shipped to your location, we can definitely do that for you. At which point, once that code is created, we can go ahead and make that part of the SOP for all deliveries for your organization so that you can be assured that the switch itself will have the custom code and the settings as you have laid out.
Okay, and the next question we got in is, are guest network changes also extended?
In the first generation of this product, they are not. The SSID and password for the primary SSID for the gateway is what is extended over. The reason for this is that if you wanted to have, say, a second, third, or fourth network SSID that you wanted to be static, that you can go ahead and do that without having to worry about the gateway itself affecting a change. But that is an excellent point, and we'll be sure to incorporate that into a later release of Wi-Fi Extend.
And I actually just got one more additional question in. Is the power adapter only single phase?
No, the power grid units will hop phase, right, Walter?
Yep, it's two-phase.
Yeah, it is dual-phased.
Okay, and that's all the questions I'm seeing. So if you just wanted to go ahead and close things out.
For closing, what we have is, thank you all for attending. I hope you're as excited as we are about Wi-Fi Extend and TR69 within the access points. If you have any other questions regarding these products, please feel free to reach out to Comtrend via Comtrend Connection or via your dedicated Comtrend sales rep.
Okay, great. Well, thank you.
Then additionally, samples are available for both the power grid units, gateways, and Wi-Fi Extend. So please reach out to your Comtrend sales rep or directly to Comtrend Marketing at Comtrend Connection, and you'll be good to go.
All right, thanks everyone. That concludes today's presentation. Thanks for attending, and thanks to Power Intel and Comtrend for getting us through all that great information.